Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're going to be multiplying 6's, and we're going to be multiplying 6's using scaling. Scaling is an interesting idea in multiplication and a different way of thinking about multiplication than maybe you've seen before. So let's think about it together today. Let's start off with the idea of scaling. Scaling has to do with making things bigger or smaller. But we need to have something to measure first to make things larger or smaller. So I'm going to give myself a unit measure down here. So down here I have just a line. And this line has just a measure of 1. I'm going to call it 1. From this, everything I do is going to be made bigger or smaller. So what does that look like? Well, if I have a measure of 1 here, and I want to make a line that's twice as tall as this, well, I have to go twice as tall, right? So if I draw a line here, this is the same height as the first one. But if I go one more measure, I'm at twice as tall, right? So this line is twice the measure of this line, and this line is only 1 times the measure of itself. Okay, what if I want to keep growing and growing? Let's do that. What if we wanted a line that was 3 times as bigger? Okay, 3 times bigger would look like this. A measure of 1, twice the measure, 3 times the measure of the first one. Okay, so this line is 3 times as tall as our first line. Keep growing. Next line will be taller than that. 1 measure, 2 measures, 3 measures, 4 measures tall. Okay, so it's 4 times as tall as our first. All right, keep growing. The next one, starting at the base, growing by 1, 2, 3, 4, 5 measures. This one, at 5 measures compared to our first measure, is 5 times taller. Look how tall it is compared to the first one. That's 5, and this is only 1. Our next one, growing, growing, growing. Start with the base. 1 measure, 2 measures, 3 measures, 4 measures, 5 measures, 6 measures. So tall. So this one is 6 times the measure of the first one. The next one, 1 measure, 2 measures, 3 measures, 4 measures, 5 measures, 6 measures, 7 measures tall. So this one has to be 7 times as tall as our first one. The next one, still growing and growing. Let's measure. 1 measure, 2 measures, 3, 4, 5 measures, 6 measures, 7 measures, 8 measures tall. All right. 8 measures tall means this is 8 times as tall as our first measure. Let's do one more. This won't be the tallest of all, right? From the base, 1 measure, 2 measures, 3 measures, 4, 5, 6 measures, 7, 8, 9 measures tall, the tallest of all. That tells us that this is 9 times as tall as our first measure. Well, that's all really good, but how does that help us with 6's? Let's think about that for a bit. What I'm going to do now is I'm going to make a stack of 6 boxes, and then we're going to grow that stack taller and taller and taller to think about scaling. So let's start. If I have one stack of 6 boxes, it looks like this. Okay, but how many boxes are there altogether in one stack of 6 boxes? Well, there's just 6 boxes here, right? But what if I want to double this stack of 6 boxes? How many boxes will I have altogether then? Well, let's see. 1 stack of 6 boxes, 2 stacks of 6 boxes. Well, it's twice as tall as the first stack, right? How many boxes are there? Well, I have 6 and 6 more. That gives me 12 altogether. So 12 boxes. So 2 stacks of 6 boxes gives me 12 boxes altogether. Look how tall the stack is. This is twice as tall as this one. What about 3 stacks of 6 boxes? 1, 2, 3 stacks of 6 boxes. How many boxes? Well, 6 and 6 is 12. 12 and 6 gives me 18. That's great. 18 is 3 times as much as 6. What about 4 stacks of 6 boxes? 1, 2, 3, 4 stacks of 6 boxes. How many boxes altogether? 6, 12, 18, and 6 more, 24. 6 times as many here. 4 times as many boxes. 6 times 4 gives us 24 here. So 6 and 6 and 6 and 6. 24 boxes, which is 4 times as many boxes as 6. What about 5 stacks of 6 boxes? 1, 2, 3, 4, 5 stacks of 6 boxes. How many boxes altogether? 6, 12, 18, 24, and 6 more, 30. 30 is 5 times as many boxes as the first measure, which had only 6 in it. 6 stacks of 6 boxes. 1, 2, 3, 4, 5, 6. Look how tall it is already. How many boxes altogether? 6, 12, 18, 24, 30, and 6 more, 36. So 6 stacks of 6 boxes is 6 times as much as 1 stack of 6 boxes. 7 stacks of 6 boxes. 1, 2, 3, 4, 5, 6, 7. So tall. How many boxes altogether? 6, 12, 18, 24, 30, 36, and 6 more, 42. That's a lot of boxes. So this stack has 7 times as many boxes altogether as our first stack. 8 stacks of 6 boxes. 1, 2, 3, 4, 5, 6, 7, 8 stacks of 6 boxes. Hope it doesn't fall over. How many boxes altogether? 6, 12, 18, 24, 30, 36, 42, and 6 more, 48. 8 stacks of 6 boxes gives us 48 boxes altogether. 8 times as many as what we started with. So you can see how much it's grown and grown and grown. Let's do one more big stack. 9 stacks of 6 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. What a giant stack. What a very tall stack. How many boxes altogether? 6, 12, 18, 24, 30, 36, 42, 48, and 6 more, 54. 9 stacks of 6 boxes gives us 54 boxes, which is 9 times as many as what we started with. So you can see how things grew and grew and grew when we think about numbers in terms of scaling. Now I'm going to ask you to look at one other thing. Let's think about scaling in terms of growing and shrinking. So we started here at 1, and we grew to twice as many, 3 times as tall, 4 times as tall, 5 times as tall, 6 times as tall, 7, 8, 9 times as tall as the first stack of 6. So we can think about things in terms of things growing and growing and increasing and increasing and increasing. So we can see that 9 stacks of 6 boxes is 9 times as tall as the first one. But we can look at some other things too. If we look at 3 stacks of 6 boxes here, we can see that 6 times those boxes is twice as tall as this one. So compare 3 stacks of 6 boxes, this one, with 6 stacks of 3 boxes. Okay, so 6 stacks of 3 boxes is twice as tall. Now scaling may be about things growing, but they're also about things shrinking. Let's go the other way. If we look at 6 stacks of 6 boxes and we shrunk it by half, what if we said we wanted a stack only half as tall? So this is 6 boxes 6 times tall. Okay? Half that many would be just 3 stacks of 6 boxes. So we can see how things can shrink as much as they grow. And that's a special idea in scaling. And that helps us think about multiplication in a very interesting way. I hope this has been helpful to you.